This is day 6 of Advent of Cyber 2024, and this challenge is called If I Can't Find a Nice Malware to Use, I'm Not Going. Mayor Malware slammed his hand on the table, his eyes narrowing as the report flashed on his screen. Glitch and McSkitty had uncovered his trail. He took a deep breath, calming himself. No matter, he muttered, a sinister grin forming. They may have found me, but haven't stopped me. His confidence stemmed from the malware he had crafted, so devious and advanced that it would easily evade detection. But before unleashing it to wreak havoc on SOC teams and ruin SOCmas, there was one final step. He needed to test it in a sandbox. So, the learning objectives for this are to analyze malware behavior using sandbox tools, explore how to use Yara rules to detect malicious patterns, learn about various malware evasion techniques, and implement an invasion technique to bypass Yara rule detection. So for this challenge, we don't need the attack box, but we need to start the machine, and it should open up in the side screen like this, and we'll be able to do this challenge within this machine. So if you're not running it like this, and you want to connect to the VPN then RDP you'll be able to do so. So when this starts up, you'll get an IP address for this machine, and you RDP into it, and then use these credentials to get in. So, detecting sandboxes. A sandbox is an isolated environment where malicious code is executed without affecting anything outside the system. Often, multiple tools are installed to monitor, record, and analyze the code's behavior. Mayor Malware knows that before his malware executes, it needs to check if it is running on a sandbox environment. If it is, then it should not continue with its malicious activity. To do so, he has settled on one technique, which checks if the directory C program files is present by querying the registry path, HKLM, software, Microsoft, Windows, current version. The value can be confirmed by visiting the registry path within the registry editor as shown below. So to open the registry editor, navigate to Start, select Run, then enter regedit. This directory is often absent on sandboxes or other virtualized environments, which could indicate that the malware is running in a sandbox. Here's what it looks like in the C programming language. So they've created a function called registry check. They've set a variable for registry path, and that is equal to the location in the registry where the current version value is. And then they've also got a variable for the value name, which is program file stir. Created a variable which will hold a character. They've created a variable command, and it has it's a character array with 512 items it can hold, or in other words, a string. And they're now building the command for what will be ran. Then they're running the command and checking to see if it was successful. So, can Yara do it? Mayor Malware knows that McSkitty is a big fan of Yara rules. Yara is a tool used to identify and classify malware based on patterns in its code. By writing custom rules, analysts can define specific characteristics to look for, such as particular strings, file headers, or behaviors, and Yara will scan files or processes to find matches, making it invaluable for detecting malicious code. Mayor Malware does not think such a simple tool can detect his malware, but just to be sure, he has to test it out himself. To do this, he wrote a small script that executes a Yara detection rule every time a new event is added to the system monitor log. This particular Yara rule detects any command that tries to access the registry. So with this one, the description is detect sandbox by querying the registry key for program path, and the strings it's looking for is a command with software, Microsoft Windows current version, and program files directory. So for his testing, Mayor Malware has set up a one function script that runs the Yara rule and logs a true positive in ctools yaramachines.txt. Open up a PowerShell window, navigate to ctools directory, and use the following command to start up the EDR. So in our sandbox virtual machine, open up PowerShell. We will navigate to that directory, so do cd, then c:\tools, then enter, and let's take a look at what's in this directory. And we can see there's jinglebells.ps1 and then yara matches.txt. So we'll first execute jinglebells. So it's now saying no events were found that match the specified selection criteria. So no events found in sysmon log, and no new events. So this tool will run on the system and continuously monitor the generated event logs. It will alert you if it finds any activity event that indicates the registry mentioned above key is being queried. So we've got that running. Now what we need to do is open up File Explorer. We will then go this PC, C tools, and we'll go into malware, and we will now run merrychristmas.exe. Okay, well, I'm now getting spammed by this. So I was running it, it wasn't popping up with anything, and I then went into the PowerShell, then did Control-C to try quit from it and rerun it, and now it's coming up with all the times I tried to run the program because I thought it just wasn't working. So let me close these notifications, but after running this we can clearly see that there is now a flag here, and it says in here we've witnessed the pop-up by our EDR with a flag included, as shown below. This will be the answer to question 1 below, so we may as well go down to question 1 and enter this in. So question 1, was a flag displayed in the pop-up window after the EDR detects the malware? That is THM glitch was here. And submit that. So now let's go back to where we were and try exit from all these. So it says we can, if answered it, we can now exit the custom EDR by pressing Ctrl+C. We've now exited it from it, so now let's go on to the next one. So adding more evasion techniques. It seems that Yara can detect the evasion that Maya malware has added. No worries, because we can make our malware even stealthier by introducing obfuscation. So it's now changed. So the encoded command is in base 64. So now, so that's running, and PowerShell-encoded command, which will run the encoded command. Sorry, the above code does the same thing, query the same registry key to get the information about the program data. The only difference is that the query is now encoded using base 64, and the code uses the PowerShell to execute the query. The encoded string can be checked by decoding it using a tool like CyberChef. So it's still doing the same thing. Get item property, path, going to the registry current version, and outputs the program file stir. Beware of floss. While obfuscation is helpful, we also need to know that there are tools available that extract obfuscated strings from malware binaries. One such tool is floss, a powerful tool developed by Mandiant that functions similarly to the Linux strings tool, but is optimized for malware analysis, making it ideal for revealing any concealed details. To try out floss, open the PowerShell window and enter the following command. So what we can do is floss, from the floss directory, run floss.exe, and we can run it on merrychristmas.exe. Actually, that needs to be malware, then merrychristmas.exe, and out file can be c tools malstrings.txt. Okay, so that's finished running. Let's go to File Explorer. We can go to Tools, and in here is now malstrings. And we've extracted all the strings that are in this executable, and we can now do Control F and find what? THM. Do next, and we found hidden clue. So let's copy this now, and we can add it to the answer, which is right here, and submit. So those were all the questions done, but I'm going to continue reading through the rest of this. Using Yara rules on sysmon logs. These Yara rules are becoming a pain to malware's backside. If he wants his malware to be undetectable, he needs to research how Yara rules can be used to stop him. For example, his research tells him that Yara rules can also be used to check sysmon logs for any artifacts left by malware. He will need to test this as well. Sysmon, a tool from Microsoft's sysinternals suite, continuously monitors and logs system activity across reboots. This Windows service provides detailed event data on process creation, network connections, and file changes. Valuable insights when tracing malware behavior. A Yara rule will look for events with event ID 1 process created for this to work. There are many entries in the sysmon log. To make it easier to find the event we are looking for, we will apply a custom filter using the event record ID that we can see in the log Yara matches.txt located in Tools. So if we go to File Explorer, we may as well just open it from here instead of doing PowerShell. So Yara matches, so event record ID, so there's that number there, the ID for the event. So note down the event record ID. We'll use the value to create a custom filter in the Windows Event Viewer. So you would open Windows Event Viewer by clicking on its logo in the taskbar, and on the left hand side navigate to Applications, Service Logs, Microsoft Windows Sysmon Operational. I won't do this, but right here is Windows Event Viewer, this application shortcut right there. So you could do this. So you'd go to this location, Sysmon Operational, then continue by navigating to Filter Current Log on the right hand side of the screen. You would see a window like this. So navigate to XML and tick the checkbox Edit Query Manually. Then click Yes to confirm. Finally copy the following filter into the box. So there's Query List. So this will contain a list of queries you're making, then an individual query here, which you've given an ID of 0, and you've set to query Microsoft Windows Sysmon Operational, and the specific path is Microsoft Windows Sysmon Operational, and you are wanting to monitor the system with an event record ID of this event ID here. So replace the event record ID value with the one you recorded before, apply the filter by clicking OK. Now you get the event related to the malware. So click on the event, and then on the Details tab, you should get the following output, which is this. So let's take a look at the event data that is valuable to us. So the parent image key shows us which parent process spawned the cmd.exe process to execute the registry check. We can see it was our malware located at or the Merry Christmas malware. The parent process ID and process ID keys are valuable for follow-up research. We could also use them to check other logs for related events. The user can help us determine which privileges were used to run the cmd command. The malware could have created a hidden account and used that to run commands. So if we look here, it was the administrator account that ran it. The command line key shows which command was run in detail, helping us identify the malware's actions. So command line, yeah, we can see it. So cmd exe and registry query current version. So that was a command which was within Merry Christmas or exe. And the UTC time key is essential for creating a time frame for the malware's operation. This time frame can help you focus your threat hunting efforts. And in the case of this, it was ran on the 11th of October. Mayor Malware leaned back, tapping his fingers thoughtfully on the table. All of this research had revealed an unsettling truth. His malware, as cunning as it was, wasn't yet ready for the wild. There were too many tools and too many vigilant eyes, analysts armed with Yara rules, Sysmon, and a host of detection techniques that could expose his creation before it even had a chance to spread. He clenched his fist, a determined glint in his eye. Just a little more fine-tuning, he murmured. He would study, adapt, and evolve his malware until it was truly undetectable. When the time was right, he would unleash it upon the unsuspecting SOC teams, striking when they least expected it. But for now, he would wait, watching, planning, and he was perfecting his craft in the shadows. Alright, so that is day 6 of Advent of Cyber 2024 completed. If you like this video, make sure to like and subscribe.